We will be looking at biogeochemical cycles. This is where elements, or you can think of atoms, must be recycled by Earth's living and non-living entities. This is, of course, important for organisms because this means that without these cycles of recycling, which is basically what it is, recycling these elements, these atoms, the essential elements would deplete. Just recall that we will not be making new atoms. We are basically recycling them. And the first cycle that we're going to be looking at is the water cycle, which most of us will find very interesting because we've probably never thought of this before. And so you look at the sea, for example, and these values are given here. We see that these in these boxes are storage. And the key here says thousands of kilometers cubed, and so these are big numbers. But here you see this big number of about 1.3 million in the sea. And we're not going to look at all these arrows, but if you follow this one right here that's moving up, well, that's the evaporation arrow over the oceans. And you see this number of 436. Again, we're not looking at all of these. We see that this arrow right here, this 111, is going to be the total precipitation, which are these two arrows of snowfall and rain, where the water basically drops back down to the earth. Forests are important for water recycling because you can see that these arrows are going in two different directions. There will be evaporation from the forests with this 29 moving up. Of course, precipitation moving down with this 54 moving down. What else can we look at? Groundwater is an important concept. It is the water that's trapped in the earth. And you can see that this is, again, this box tells you that it's being stored there at 23,400. The one that is probably most interesting to those listening is going to be this domestic, which is the humans that are living on the earth, and what are they going to do with their water? Well, notice that this is a very small piece of the pie. This 0.38 here is a very small number compared to these other numbers that we've looked at. On the other hand, when we think about all of the different houses and all of the different businesses, all of the numbers of toilets that you have in a city, we're talking about sewage that needs to be taken care of and treated. And most of us don't even think about this, but there's a whole process here for wastewater treatment that's taking place in all of the cities around the country. And so let's look at some of these. So wastewater comes out of these houses and businesses. Every time you flush a toilet, you are contributing to it. When you think about it, this wastewater is going to have solids in it that need to be removed. And so most of this early part of this wastewater treatment will be in order to get rid of solids. Now, when these solids get removed, the term that we use for these solids is known as sludge. And this sludge has to be dealt with as well, and there's different ways to deal with it. Sometimes we can use it as fertilizer. But most of the time, we will take this sludge and have to remove it somehow. You can see this truck taking the sludge somewhere. In this diagram, it says incineration facility, but oftentimes these trucks actually take this sludge to landfills and dump it there with the rest of the trash that humans are contributing on a minute-by-minute basis. Okay, what happens once most of this solid material is removed? Well, the water's still not good enough for drinking purposes, of course. There's going to be a secondary treatment here where we remove more material. Oftentimes we use microbes, bacteria, to digest a lot of the organic material. So we actually put microbes in these tanks that will start breaking down the organic material from our sewage, and they will be doing that through their aerobic respiration. There's going to be this sludge that accumulates again, and this sludge will have to be removed again. At this point, the water will look pretty clear when we're at this point, and so it will look like it's clean water, almost ready to drink, but of course there will still be microscopic material that can be dangerous for health if the water is consumed. And so in the last phases of this water treatment, we will be putting chlorine inside the water. And as we know, chlorine is going to kill the remaining microorganisms, so that once water finally does make its way back into circulation for our homes and comes out of our faucets, for example, that water will be safe to drink so that we are not making our populations sick.